Friends, today is that is system. In communication system, we are going to discuss what is communication system, and we have the generalized communication system block diagram is there, and we are going to discuss the different terms. Okay, so here some of the terms related with the communication system, that all we are going to discuss here. Yes, so we are just expecting 1 marks from this lesson because the semiconductor and communication system usually So let us discuss the terms which we are going to study in this communication system. So the first term is, what do you mean by communication? So communication anta andrenu. Here the communication is nothing but what? It is the sending and receiving the information from one place to the other place. Sending and receiving the information from one place to the other place is called as what? Communication. Okay. Then here we have the two basic modes of communication. So what are the two basic modes of communication? That is, first one is point to point communication. It is point to point communication. And the second one is broadcast communication. And the second one is broadcast communication mode. So these are the two communication modes which we have here. Then next, here point to point communication mode. So what is point to point communication mode? In this mode, the message is transmitted over a link between single transmitter and a receiver. So point to point communication from the receiver, from the signal transmitter to the receiver. So in one line, it will just, the message will pass. So this is an example for this one is, that is telephone. Okay. Then what is broadcast communication? Broadcast communication examples are radio and television are the example here. Here the large number of receivers corresponding to the single transmitters will be there. Here only one single transmitter and a receiver. Here many receivers will be there in case of broadcast communication. Okay. So the different types of transmission medias are there. That is nothing but air. Then we have water medium. Then we have copper cables, then we have optical fibers, and we have vacuum tubes. So these are the different modes of the transmission media. Yes. Then next, let us see the communication system parts, different parts of the communication system and nodana. So we have the block diagram here. The block diagram is, that is given by, so first one, it is information source. The first one is information source. Then next we have the transmitter. So il transmitter baratte. So here we will consider the message signals are passing through this. Then next we have the channel. Okay. Then next here the unwanted, whatever the message is there, that will be taken to the noise. Then here we have the receiver. Then last one we have user information or use of information. So that is use of information. Okay. So this is about the block diagram of this generalized communication system. Now let us see what is the work of this different parts, whatever we are using here, that is given by, for example, first one, it is a signal. So what do you mean by signal here? Signal is nothing but what? It is the electrical form of the information. The signal is defined as the electrical form of the information is called as what? Signal here. The electrical form of the information is called as signal. Okay, so we have two types of signal. Can anyone tell me what are the two types of signals? What are the different types of signals, or the two types of the signals? What is that name? It is analog signal and the digital signal. Howda? So analog signal and the digital signal are the two types of the signals here. Then next part in this communication system is, that is transducer anta barutte. So signal admele now transducer ಬಗ್ಗೆ study ಮಾಡ್ತೀವಿ. So what is transducer here? It is a device which converts energy from one form to another form. It will convert energy from one form to another form. That is called as a transducer. Then we have the next part, that is a noise here. Noise is nothing but what? Unwanted signal. So the unwanted signal which tends to distribute the transmission and the processing the message is called as what? Noise here. Okay, then the next part is transmitter. Then the next part we have the transmitter. So what is this transmitter is doing? Again, it is a device which will convert message signal. It will convert the message signal into suitable transmission through the channel. So it will convert the message signal to the suitable frequency anta kuda navilli heltivi. That is the use of the transmitter. Then next here, attenuation. We will study the term attenuation anta barutte. So attenuation anta andre enu? Here this attenuation is nothing but what? The loss of strength, the loss of strength of a signal. The loss of strength of a signal is called as what? Attenuation. Then next we have the term called as amplification. So what is amplification? This amplification is nothing but it is the increasing the strength. The increasing the strength of the signal. This process is called as amplification anta karitare. Aita ಕಡೆಗೆ ನಮಗೆ ಇಲ್ಲಿ ರೇಂಜ್ ಅಂತ ಬರುತ್ತೆ. ರೇಂಜ್ ಅನ್ನ ಯಾವ ತರ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ? It is the largest distance. It is the largest distance between the transmitter and the receiver. Between the transmitter and the receiver, the largest distance is called as, it is range. The range is the largest distance between the transmitter and the receiver. The next we have the bandwidth. So how do you define the bandwidth? The bandwidth in the communication is defined as, it is the range of frequency. Bandwidth is defined as the range of frequencies over which communication system works. That is called as bandwidth. Then next, the definition is carrier wave. The carrier waves. So carrier waves are nothing but what? High frequency waves used to modulate the low frequency. High frequency waves used to modulate the low frequency wave is called as what? Carrier waves. Okay. So these are the terms related to our communication system. Then next, here one method we are doing, that is a modulation. So what is modulation? Why it is required? The modulation yak bekagatte antande to reduce the size of the antenna. So here the use of modulation is what? To reduce the size of the antenna, we require modulation. To increase the effective power, to increase the effective power radiated by the antenna. So to increase the power ge use ಮಾಡ್ತೀವಿ modulation anna. To avoid the mixing. So to avoid mixing up of signal. So mixing up of signals ಅನ್ನ avoid ಮಾಡ್ಲಿಕ್ಕೆ modulation ಮಾಡ್ತಾರೆ. ಮತ್ತೆ fourth use ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ, to propagate low frequency signals to a long distance. To a long distance, we are doing this modulation process. By demodulation, demodulation ಅಂದ್ರೆ ಏನು? So demodulation define ಮಾಡ್ತೀವಿ. It is a process of retrieval of information is called what? Demodulation ಅಂತ ಹೇಳ್ತಾರೆ ಆಯ್ತಾ. ಸೊ ಮಾಡ್ಯುಲೇಷನ್ ರಿವರ್ಸ್ ಪ್ರೊಸೆಸ್ ಡಿಮಾಡ್ಯುಲೇಷನ್ ಅಂತ ಆಗುತ್ತೆ. ಓಕೆ, ದೆನ್ ನೆಕ್ಸ್ಟ್ here some of the important values we have, that is the frequency range for the signal speech. So speech ಗೆ the frequency range ಎಷ್ಟು ಬೇಕಾಗುತ್ತೆ? It is 300 hertz to 3100 hertz. So remember these all points so that we can discuss while solving the question answers. Okay, then next we have, that is the bandwidth. Idu frequency aitu, kadege bandwidth estide nodi. The bandwidth value for the signal speech is 800 hertz. It is 800 hertz. Okay, then for the TV signals, so for TV signals the bandwidth is, it is 6 megahertz. It is 6 megahertz. Okay, the bandwidth for the digital data, the bandwidth for the digital data, it is infinity rate value. Right? Then we have the coaxial cables. So idra ಮೇಲೆ question ನಾವು expect ಮಾಡಬಹುದು. So the coaxial cables ಗೆ the bandwidth value is, it is 750 megahertz. ಇದು ಎಷ್ಟು ಬರುತ್ತೆ? 750 megahertz ಅಂತ ಬರುತ್ತೆ. Then optical fibers. So for the optical fibers, the value of bandwidth is 10 to the power of 11 hertz. So these are the some of the important values. Idra ಮೇಲೆ one question ಬಂದ್ರು ಬರ್ಬೋದು. Bandwidth and the frequency values we have written here. Okay, the next last part of this lesson, that is we will discuss the waves here. Some of the waves we discuss, like wave and sky wave, and what are the three waves which we will discuss here? So the ground wave is also called as surface waves, and after that what is the more wave? Three waves discuss ಮಾಡ್ತೀವಿ. So here we have, that is sky wave. Students, PPT is,
Yes, ma'am.
yes, ma'am. Okay. So here the first one, that is the ground wave. The ground wave is also called as the surface waves. So these are the radio waves which transmit from antenna to the receiving antenna after reflection from the surface of the earth. So ground wave athwa surface wave enagutte antandre, it will transmit from transmitter to receiver after reflection from the earth surface. Then next we have the sky waves. So these are the waves which will transmit from the transmitting antenna to the receiving antenna after So the ground waves are reflected from the surface of the earth. Sky waves are reflected from the ionosphere. Similarly, the space waves are reflected from the transmitting antenna to the receiving antenna, and it will propagate straight. The propagation of these waves are straight here. So the distance between the radio horizon of the transmitting antenna, the distance is calculated as under root of 2RH. So now idar mele ninne questions anna discuss madidvi. Now we will go directly for the questions of this lesson. Okay. So our first question is, yes. So here is our first question. Which of the following cannot travel in vacuum? That is the radio waves, gamma waves, infrared waves, and infrasonic waves. So which will not travel in vacuum? Infrared wave is an electromagnetic wave. Howdala? So we know that now electromagnetic waves lesson discuss madbekadre enanta heltivi, all the electromagnetic waves can travel in a vacuum as well as in the medium anta. Yes, option D is correct. That is infrasonic waves. Infrasonic waves cannot travel in vacuum. Then the next question. What is the electrical analog of the information produced by the source? Attenuation, amplification, signal modulation. Yes, Akash is saying option C. Sinchana, Damini. Yes, correct. That is signal. Answer is signal here. So the electrical analog of the information produced by the source, it is called as the signal. So simple questions irutte communication system mele. Next question. What is defined as the largest distance between the source and the destination up to which a signal can be received with sufficient strength? Yes. Students, mute yourself. It is called as, yes, correct. So this is called as what? Range here. So range is the correct answer. Option B is 100% right. Then the next question. Identify the device which is a combination of a transmitter, an amplifier, and a receiver which picks up a signal and a retransmit it. So you need to identify the device. Which is a combination of. So idರಲ್ಲಿ ಏನೇನ್ ಬರುತ್ತೆ ಅಂತಂದ್ರೆ transmitter, amplifier ಮತ್ತೆ receiver ಇರುತ್ತೆ. So that combination is called as. Correct. A or B it is. Yes, right. So very good. That is option B. Repeater is the correct option here. Repeater is the correct option. Okay. A baralla, B baratte, bro. B is correct. Then the next question. What refers to the band of frequencies of the original signal? What refers to the band of frequencies of the original signal? Range, broadband, bandwidth, baseband. What refers to the band of frequencies of the original signal? So Tarun, Kumar, Abhishek, you people are right. That is option C, bandwidth. Is very good, Vidya. That is bandwidth. That is the band frequency of the original signal is called as bandwidth anta heltare. Then the next question. X refers to the frequency range over which equipment operates, or the range over which the frequencies in a single signal vary. Identify X, whether it is a range, repeater, bandwidth, or the baseband. Yes. So Damini is saying option C. Abhishek is saying option C. Kumar, Tarun, option D. Nandish, Vidya. Yes. So it is option C. Bandwidth is correct. Option C. Bandwidth is correct. Okay. Then the next question. A transmitter is a device that that recovers the original message signal from the signal received at the output of the communication channel. So here ಏನಂತ ಹೇಳ್ತಿದ್ದಾರೆ ಅವರು ಟ್ರಾನ್ಸ್ಮಿಟರ್ ಒಂದು ಡಿವೈಸ್ ಇದೇನ್ ಮಾಡುತ್ತೆ recovers the original message signal from the signal received at the output of the communication channel. So ಇದು ಟ್ರಾನ್ಸ್ಮಿಟರ್ ವರ್ಕ್ ಆಗತ್ತಾ ಬೇರೆ ಯಾವ ಡಿವೈಸ್ ಆಗತ್ತಾ? So whether it is a true or false. It is true. ನಾವು ಈಗಷ್ಟೇ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಲ್ಲ what is transmitter, what is transducer. Baseband we don't have only baseband ಬರಲ್ಲ ನಮಗೆ ಇದರಲ್ಲಿ. Yes, it is false it is false. So it is a work of a transducer ಆಯ್ತಾ. ಟ್ರಾನ್ಸ್ಡ್ಯೂಸರ್ ಕೆಲಸ ಅದು ಏನ್ ಮಾಡುತ್ತೆ ಒರಿಜಿನಲ್ ಸಿಗ್ನಲ್ಸ್ ಅನ್ನ ಮೇಂಟೈನ್ ಮಾಡೋದು ಟ್ರಾನ್ಸ್ಡ್ಯೂಸರ್ ಆಗತ್ತೆ. So it is a false. Yes, next question. What is the loss of strength of a signal during its propagation called? So loss of strength of a signal during its propagation is called as attenuation, amplification, bandwidth, noise. Loss of strength of a signal during its propagation is called as. Yes. So ಎಲ್ಲರೂ ಕರೆಕ್ಟ್ ಆಗಿ ಹೇಳ್ತಿದ್ದೀರಾ. That is option A, 100% right. Attenuation. So ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ ನಾಯ್ಸ್ ಅಲ್ಲಿ ಅನ್ವಾಂಟೆಡ್ ಸಿಗ್ನಲ್ಸ್ ಇರುತ್ತೆ, ಬ್ಯಾಂಡ್ ವಿಡ್ತ್ ಅಂತಂದ್ರೆ ರೇಂಜ್ ಆಗುತ್ತೆ, then amplification is increasing. So loss of strength of a signal during its propagation is called as attenuation. Option A is correct. Then the next question, what is mean by the term communication? So communication ಅಂತಂದ್ರೆ ಏನು? Transfer of the information, transfer of bytes, transfer of knowledge, transfer of funds. So which is correct here? What is meant by the term communication? A, C. Transfer of knowledge illen transfer ಮಾಡಿ knowledge ಯಾವ ತರ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ communication. The basic definition is hauda. So transfer of information is correct here. Transfer of information is the correct option. Option A is right. Then the next question, name the device which converts energy from one form to another. So you need to name a device which will convert the energy from one to another. Transformer, modem, transducer, repeater. So which device will come? Convert energy from one to another. A, yes. So A or C it is. Harshita, Damini, Akash. Yes. Sure, Allah. Option C. Yes. So option C, that is transducer is correct. Option C, transducer is correct. Then the next question, name the process of recovering the original information signal from the modulated wave at the receiver end. Name the process of recovering the original information signal from the modulated wave at the receiver end. It is called attenuation, demodulation, modulation, or bandwidth. Yes. Name the process of recovering the original information signal from the modulated wave. It is demodulation. Or modulation. Yes. Demodulation antara modulation antara confirm agi heli nodana. I think still you will have the confusion in the definitions. Haudalla? Because still you are not sure. Bandwidth ಅಂತಂದ್ರೆ ಇನ್ನು attenuation ನಾನು ಫಸ್ಟ್ ಅಲ್ಲೇ ಹೇಳಿದೆ ಅಲ್ಲ ನಿಮಗೆ modulation demodulation. Yes. Here the process of recovering the original information signal from the modulated wave is called as demodulation anta ಹೇಳ್ತಾರೆ. It is option B. Option B is correct here. Okay, option B baratte, not option C. Yes. Then the next question. Name the process. Okay, the frequency. Sorry, this one is not completed. No, this one. This one is over. Next question is this. The communication system needed for a given signal depends on which of the following: band of frequencies, length of the channel, size of the transmitter, size of the collector. The communication system needed for a given signal depends on which of the following: band of frequencies, length of the channel, size of the transmitter, size of the collector. Yes, very good. So it is band of frequencies. Band of frequencies, option A is correct. Option A is correct. Then the next question, what is the frequency range for a speech signal? What is the frequency range for a speech signal? 20 hertz to 20 kilohertz, 20 kilohertz to 20 megahertz, 300 hertz to 3100 hertz, 30 hertz to 310 hertz. Yes, we discussed this one. Now we just discuss madidvi. It is option C, 300 to 3100 hertz. Then the next question, the frequencies for transmitting music is which of the following? Low frequency, high frequency, moderate frequency, very high frequency. The frequencies for transmitting music transmit ಮಾಡಬೇಕಾಗಿದೆ ಇಲ್ಲಿ. Moderate. Yes, Akash is right. That is option C. High ಬರುತ್ತೆ ಯಾಕಂತಂದ್ರೆ when we are transmitting music ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ musical instruments ಕೂಡ ಇರುತ್ತೆ. So musical instrument ದ್ದು ಮತ್ತು music ದ್ದು if you want to means compare frequency ಅಲ್ಲಿ ಸ್ವಲ್ಪ high frequency ಬೇಕಾಗುತ್ತೆ. Low idre ಅಷ್ಟು ಇದು ಬರಲ್ಲ. So high frequency, not very high, so just high frequency. Option B is correct here. Then the next question, a TV signal is allocated with a bandwidth of 6 megahertz. True or false? True or false? Yes. Yes, it is option A, it is true. Then the next question, a carrier of peak voltage 15 volt is used to transmit. if the modulation index is 70%, then what will be the peak voltage of the modulating signal? So here the peak voltage is 15 volt and the modulation index is 70%. Then what will be the peak voltage of the modulating signal? Harshita is saying it is option C. Can you tell the formula, Harshita? What formula you have used here? The peak voltage is 15 volt and the modulation index is 70%. We require the peak voltage of the modulating signal. Yes. Students say nobody knows. Formula. You can add yourself the formula. Here. Option D. Okay. Option D or option C? See here. Yes. See what we are going to do, that is yes. So this is the formula, that is the modulating index is equal to the modulating wave voltage upon the peak voltage. Substitute 70%. We will write it as 7 by 10. Then multiply this by 15. So whatever is it is in front of you. Option C is correct here. Yes. Okay. Let us go for the next. Then the next question. Sorry, this is repeated. Layer where ozone is present: troposphere, stratosphere, ionosphere, mesosphere. It is Which one? Identify the layer where ozone is present. Tropo, strato, ionosphere, mesosphere. It is, yes, stratosphere. Then the last question from this slide. The question is, what is the maximum distance to which the TV transmission can be received if the TV tower has the height of 220 meters? Then we will go for the previous year questions. So what is the answer for this? You tell me. Yes, correct. It is 59.3. So now either ಬಗ್ಗೆ formula ನಾವು ಇದನ್ನ discuss ಮಾಡಿದ್ವಿ ಇದೇ ತರ questions ಅನ್ನ. Now we will go for the previous year questions. Okay, that is. So the question is, in a transmitter, okay, in a transistor, actually we have a semiconductor and the communication system together. Questions are there. So here the question is, first I'll take the question on the logic gate. This is asked in 2016. That is, so this is your input A. Then this is B. So what is, identify the logic operation carried out by the circuit is. So this is the circuit what they have given. Options are AND gate, option B is NAND gate, and option C is NOR gate, option D is OR gate. Identify the logic operation carried out by the circuit. Yes. Question repeat madla. Okay, identify the logic operation carried out by the circuit is. So the circuit is in front of you. You need to identify what is your Y output. Yes, it is AND gate or an AND gate, NOR gate or OR gate. It is actually option D is right. That is the OR gate. Here, what you need to do, ನಿಮ್ಗೆ ಯಾವ ತರ ಗೊತ್ತಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ನೀವು ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ A. So you just take the value of A, means A, B. We will make a column, that is, so here it is 1, 1, 1, 0, 0, 1. The next 0, 0. At the output Y is equal to. So if, can anyone tell me whatever the, here whatever this Logic gate is there. Which one it is? ಇದು ಯಾವ್ದು logic gate ಆಗತ್ತೆ ಹೇಳಿ ಫಸ್ಟ್ ಇದ್ದದ್ದು? Which one? Yesterday you have discussed, no? It is a NAND gate, ಹೌದಾ? So NAND gate ಕೆಳಗಡೆದು B ಕೂಡ NAND gate ಇರುತ್ತೆ. So 1 1 ಇದ್ದಾಗ, so B that is for the NAND gate. If the values are 1 1, whatever output at this point ಇಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ? So ಇಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ ನೋಡಿ. Then again you need to convert that. So again here it is a NAND gate. Whatever the output you will get, you need to go on writing here. ನೀವು ಇಲ್ಲಿ ಬರ್ದಾಗ ನಿಮಗೆ ಒಂದು ಬರುತ್ತೆ, ಟೇಬಲ್ ಬರುತ್ತೆ. So whatever the table you are getting here, that is representing the OR gate. Therefore, the given circuit is denoting your OR gate here. So option D is correct. So like this questions will be there. ನಾನು ನಿಮಗೆ ಮತ್ತೊಂದು ಇಲ್ಲಿ simplify ಮಾಡಿ ತೋರಿಸ್ತೀನಿ. That is so here that kind of examples we will take. This is A, this is B. The circuit diagram shown prefers the logic function of. So the options are given. Option A is a XOR gate and option B is a AND gate. Option C is a NAND gate and option D is a OR gate. How to do that? Here the first logic gate you have. This logic gate is representing your NAND gate. Howda? So NAND gate alli, if you consider as A, B and Y, in case of an AND gate, so this is 0 0 1 0 0 1 and it is 1 1. Yes. Yesterday we have discussed what we will get in case of an AND gate. In case of an AND gate, our output is, so the output is sorry, the diagram I'll draw it once again. The circuit is somewhat like this. This is your A, this is your B. Okay, this is our Y. So what I was telling you, that is A, B and Y. So this is 0 0 1 0 0 1 then 1 1. So for the NAND gate, here the output is, it is 1 1 1 1 1 iddaga 0 anta barutte. So now here whatever it is there, it is the negation of that. So negation of that means here whatever value you are getting, 1 iddaga 0 agutte, 0 iddaga 1 iddaga again 0 0. So this is 1. So this is which table it is? It is 0 0 0 1. So only when 1 1 is there, we have the output 1. Other than that, all the values are 0. So this is nothing but your AND gate. Yes. Yes, correct. Very good, Rakshita. So this is nothing but the representation of the AND gate. So therefore, so in the given options, XOR gate is there, AND gate is there, NAND gate is there, OR gate is there. That is option B is correct. It is. I hope it is clear to you. ಸೊ ಇಲ್ಲಿ ಫಸ್ಟ್ ಯಾವ್ದು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ನೋಡ್ಬೇಕು. ಇಲ್ಲಿ ನ್ಯಾಂಡ್ ಗೇಟ್ ಇದ್ದಾಗ ಸೊ 1 1 0 0 ಏನ್ ಬರುತ್ತೆ 1 ಬರುತ್ತೆ 1 0 1 0 1 ಇಟ್ ಇಸ್ 1 1 1 ಇಟ್ ಇಸ್ 0 ಹೌದಾ. ಸೊ ಇಲ್ಲಿ ನಮ್ದು ಏನಾಗುತ್ತೆ ಇದು ನೆಗೇಷನ್ ಆಗುತ್ತೆ ವ್ಯಾಲ್ಯೂಸ್ ಹೌದಾ. ಸೊ ಇಟ್ ಇಸ್ 0 0 0 1 therefore ವಾಟ್ ಎವರ್ ದ ಫೈನಲ್ ಇಲ್ಲಿ ನಿಮಗೆ ಫೈನಲ್ ಆನ್ಸರ್ ಬಂತಲ್ಲ ಇದು ಯಾವ ಟೇಬಲ್ ಅನ್ನ ಟ್ರೂತ್ ಟೇಬಲ್ ಅನ್ನ ಮ್ಯಾಚ್ ಆಗತ್ತೆ. ಸೊ that will be your respective circuit diagram, that is your AND gate. I hope it is clear to you. So if you want I'll take one more example, that is this is your A, this is your B, this is Y1 and this one is Y2. Okay, the which logic gate is represented by the following combination of the logic gates. So the options are it is OR and it is NAND gate or it is a AND gate ಅಥವಾ NOR gate ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ ಇಲ್ಲಿ. ಅಗೇನ್ ಸೇಮ್ ನೀವೇನ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ ಈ ತರ ಸರ್ಕ್ಯೂಟ್ ಡಯಾಗ್ರಾಮ್ ಮೇಲೆ ಕ್ವಶನ್ಸ್ ಬಂದಾಗ you just need to write AB and Y value. So first AB 0 0 0 1 1 0 1 1. So see A value is what I am giving it as 0. So if A value is 0 y1 y2 now separate ಆಗಿ ಮಾಡ್ಕೊಳ್ಳೋಣ ಒಂದು ನಿಮಿಷ. So ನಾವು ಇಲ್ಲಿ ಏನು ಮಾಡೋಣ ಅಂತಂದ್ರೆ we will make here y1. So ಇಲ್ಲಿ ನಂದು y1 ಏನು ಬರುತ್ತೆ ಕಡೆಗೆ ಇಲ್ಲಿ B ಆಮೇಲೆ ಇಲ್ಲಿ y2 ಏನ್ ಬರುತ್ತೆ ಅಂತ ನೋಡೋಣ. ಓಕೆ ಸೊ now A 0 ಇದ್ದಾಗ y1 will be 1, this is 0 then it is 1. ಇಲ್ಲಿ actually 4 values ಬರೋದೇ ಇಲ್ಲ, ನಾವು ಕೂಡ 2 values ಮಾತ್ರ ತಗೊಂಡ್ರೆ ಸಾಕಾಗತ್ತೆ. Here it is 1 then it is 0. Similarly B value B ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ 0 ಇದ್ದಾಗ 1 ಆಗುತ್ತೆ 1 ಇದ್ದಾಗ 0 ಆಗುತ್ತೆ. Now what is your y1 and what is your y2? y1 y2 1 1 0 0. So what is your output here? The output is ನಾವಿಲ್ಲಿ 4 values ಗೆ ತಗೋಬಹುದು. NOR gate ಅಂತ ಅಭಿಷೇಕ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. So we will see. So whatever output we'll get based on that we can tell this one. So this is 1 1. If 1 is 1, y2 is 1. Again it is a negation, therefore it is 0. Then 0 0. It is 1. Yes. So it is a NOR gate option. Next, we have one Karnataka CET 2018 question. The question is, in DC common ammeter current gain of a NPN transistor. So for the NPN transistor, the current gain is given as 50. The potential difference across the collector, and the ammeter region for the CE configuration is, it is VCE is equal to 2 volt. If the collector resistance is 4 kilo ohm, then base current will be, then what is the value of base current and the collector current? So options ನಾನು ಇಲ್ಲಿ ಬರಿತೀನಿ. That is options are IB is equal to 10 microampere and IC is equal to 0.5 milliampere. And here it is IB is equal to 0.5 microampere, IC is equal to 10 milliampere. Then IB is 5, IC is 1, IB is 1 and IC is 0.5. So I'll repeat the question. Question ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ in a NPN transistor VCE voltage 2 volt ಇದೆ, RC ಅಂದ್ರೆ collector resistance 4 kilo ohm ಇದ್ದಾಗ what is the value of base current and the collector current? They have given the beta value. ಇದು 50 ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ beta value ಆಗುತ್ತೆ, current beta value. Yes. What is the answer here, students? This 2018 question. Is it clear? Question is clear. Question clear ಆಯ್ತಾ ಎಲ್ಲರಿಗೂ? Yes. In a NPN transistor, the beta gain value is 50 ಅಥವಾ current gain value 50 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Then we have the current value, VCE value and RCE value. What is the value of IB? Base current ಮತ್ತೆ collector current value they are asking. In a DC common ammeter, current gain value is 50. The potential difference across CE configuration is 2 volt. Then the collector resistance is 4 kilo ohm. What is the value of base current and the collector current? You don't know, you know. Say something in the chat box. Question artha aita? Yes. See here. Why nobody is replying? What happened? Here the beta value, beta is equal to that is IC by IB. So we have the value beta value as IC divided by IB. So but both the values we require. Beta value is given 50 anta kottidare avaru, IC IB. So how to calculate IC IB here? We have RC value, ನಮಗೆ RC value ಗೊತ್ತಿದೆ, ಮತ್ತೇನ್ ಗೊತ್ತಿದೆ ನಮಗೆ ಇದರಲ್ಲಿ? We know the value of VCE. Nobody knows. This is option A will come C. So use the formula beta is equal to IC by IB. Here beta value is given. We have RC value. So therefore, RC is equal to VCE upon IB. So ನಿಮಗೆ CE value ಗೊತ್ತಿದೆ, RC value ಗೊತ್ತಿದೆ, ಇದರಲ್ಲಿ ನಿಮಗೆ IP value ಗೊತ್ತಾಗುತ್ತೆ. So once you get the IP value, IC by IB you can do. So like that you will get the option BA is the correct option here. That is IB is 10 microampere and